Assalamualaikum and a very good day to the audience. This video is a part of project requirement for course Asset Integrity and Risk Management. Our group, which is Group 4, consists of 5 members as per stated in the slide. For this project, our group is assigned to perform FMEA analysis for the equipment storage spherical tanks. So before we proceed, let us learn what is storage spherical tank. So storage spherical tank is a type of pressure vessel which is designed to hold gas or liquid at high pressure below the ambient temperature. So most common application of storage spherical tank is in the use of storage of LPG, LNG, propane and other hydrocarbons. So from the uniqueness of the sphere shape, this spherical storage tank provides better pressure distribution. Therefore, the tank provides high strength, especially in the use of storing medium in high pressure condition. The sphere shape also provides high storage capacity. However, any system design or production process will necessarily have risk, even with the advantages of using the spherical storage tank. This FMEA approach is crucial as it specializes in identifying and eliminating process failure for the purpose of preventing an undesirable event. It will help assist in the identification of major risks and subsequently give assistance in mitigating the effect of the risk. As seen here in the slide, this is the common FMEA template that will be used in most risk assessment nowadays. From the table, we can see that each of the failure mode will be rated into 3 categories. The severity, which is how severe the failure may harm the production, the equipment or even the environment. The second factor, which is the occurrence, which is the likelihood of the failure to happen, and the detection factor, which is the difficulty of detecting the failure. For this particular project, we will do FMEA analysis based on tank component, which are the shell, tank head, manhole, nozzle, and the support structure of the storage tank.
Moving forward to the problem statement, the spherical storage tanks are commonly utilized in various industries to store high-pressure gases and liquids, with particular prevalence in the oil and gas sector for holding liquefied petroleum gas and liquefied natural gas. However, these tanks are susceptible to failure from multiple sources, including material defects, operational errors, and environmental factors. As a result, it is crucial to identify potential failure modes and proactively implement measures to mitigate their impact to ensure the safe and reliable operation of these tanks. Therefore, a failure modes and an effect analysis (FMEA) is necessary to identify and assess potential failure modes and their impact on the tank's performance, safety, and the environment. Next, our objective is to provide an overview of FMEA and its importance in identifying and mitigating potential failures in industrial equipment. Additionally, we will focus on the specific application of FMEA in the context of spherical storage tanks. We will discuss the various components of a spherical storage tank and the potential failure modes that can occur in each of them. Our team will use a standardized FMEA template to assess the severity of each failure mode and evaluate the likelihood of occurrence and detectability. Our ultimate goal is to provide recommendations for actions that can be taken to reduce the likelihood of potential failure modes and ensure the safe and reliable operation of spherical storage tanks in industrial settings. The scope of the project is to conduct a failure mode and effect analysis (FMEA) on the 5 elements that comprise a spherical storage tank: the shell, tank head, nozzle, manhole, and support structure. The FMEA team will identify potential failure modes for each component and evaluate their impact on personnel, the environment, and the overall function of the tank. Probability of occurrence and detectability will also be assessed. The FMEA report will include recommendations for actions that can be taken to mitigate the likelihood of each failure mode.
So, I will be presenting about inspection method or known as non-destructive testing that we usually do for storage spherical tank. So, we have 5 types of inspection, which is visual inspection, ultrasonic testing, dye penetration testing, hydrostatic testing, and acoustic emission testing. So, for visual inspection, we usually do the process involves unexpected visually examining the tank surface for any sign of cracks, corrosion, leaks, or other damage. Next, we have ultrasonic testing, which involves the use of an ultrasonic transducer which is placed on the surface of the tank and emits high frequency sound wave to detect any internal defects such as cracks and corrosion. So for dye penetrant testing, we usually apply a colored dye to the surface of the tank and allowing it to penetrate any surface to detect small cracks or defects that are not visible to the eye. So we move on to the next slide. So we have hydrostatic testing. So this type of test is usually done by filling the tank with a test liquid such as water until it reaches to a predetermined level. So the tank is then pressurized to a specified level, which is typically 1.5 times the maximum allowable working pressure of the tank and held for a specific time to monitor any leaks or deformation. So lastly, we have acoustic emission testing. So for this process of testing is by attaching acoustic sensors to the surface of the spherical storage tank, and then which detects the very high frequency waves generated by the tank as it undergoes changes. So these waves are then analyzed to determine its location, type, and severity of any damage or defects in the tank. So next, I will pass the floor to Wan Amirul.
Now let's move on to the typical standards used for spherical storage tank. There are three typical standards used for construction and inspection of spherical storage tank. The first one is API 620. The standard for API 620 tanks governs the construction and design of oil and chemical tanks with a diameter of more than 300 feet, capable of accommodating contents with a pressure of 15 psi. These contents can include high-pressure liquid, gases and vapors, as well as low-temperature materials ranging from -198 degrees Celsius to 121 degrees Celsius, such as cryogenic liquid and liquefied natural gas. Second is ASME, Boilers and Pressure Vessel Code. ASME Section 8 deals with pressure vessels and includes guidelines for their design, manufacturing, examination, testing, and certification. This section applies to both fired and unfired pressure vessels exceeding 15 psig, regardless of whether they are operate under internal pressure or external pressure. The last one is API 510. API 510 standard examines pressure vessels to evaluate their ability to operate effectively and safely, including their material quality, storage capacity, measurements, and other relevant factors, both internally and externally. I will pass to the next presenter.
Now, let's move on to the equipment boundary. In this project, there are 5 equipment boundaries that are listed. The first is the shell. The shell is the major body of the tank and it is normally constructed out of steel. The advantage of the spherical tanks is that it includes better use of available space, lower surface area to volume ratio, and ability to withstand the higher pressure. The spherical shape also helps reduce impact pressure compared to cylindrical tanks. And the next is the tank head. The tank head is the rounded top or bottom of the spherical tank that completes its shape. And it is also typically made out of steel and it can endure the pressure of the material being stored. The shape and size vary based on the tank size, shape, and type of substance being stored. The tank head must be detachable for maintenance and inspection purposes. Next, the third is the nozzle. The nozzle is the opening in the spherical tank used for loading or unloading stored material, and the nozzle is placement and size depends on the material type, required flow rate, and other things. It can be placed at different points along the shell, such as top or bottom of the tank, and it is usually at the top of the tank. And it must consider substance pressure, temperature, corrosiveness, and maintenance requirements. The next equipment boundary is the manhole. The manhole is a sizable opening in the spherical tank shell for maintenance or inspection purposes. It is normally round or rectangular, located at the top of the tank, and have a removable cover or hatch for workers to access. Its design and size depends on the tank size, stored material pressure and temperature, and it must have a safe and easy access requirement. The spherical storage tanks must have manholes to allow the tank examination and maintenance to ensure structural integrity. And lastly, the support structure. The support structure purpose is to hold the spherical tank in place. The support can be separated structure attached to the tank base or integral parts of the tank made out of concrete. The support must be built to handle the tank weight, material health, and also the outside factors like wind and seismic stresses. And the support number and placement vary depending on tank size, shape, and local environmental circumstances.
Now, I will talk about failure incident related to the spherical storage tank. There are at least two major incidents involving spherical storage tank. The first incident occurred during a drainage operation of an LPG tank at a petroleum refinery in southern of France, where a drain valve froze, causing a large amount of LPG to leak. The leaked LPG spread to a nearby road and caught fire due to the heat of a passing car, which led to a massive explosion that destroyed several LPG surrounding tanks and the refinery itself. The cause of the accident was a minor human error. The incident causes at least 18 deaths and injuries of 81 people, and this incident has contributed to the development of current LPG tank regulations. The next incident is the explosion of Pemex Company Limited. The San Juan explosions were an industrial disaster that happened in 1984, caused by a series of explosions at an LPG tank farm owned by Pemex Limited. The explosion destroyed 6 large spherical tanks, 48 small horizontal cylindrical tanks, and a nearby residential areas. It causes at least death of 500 to 600 people and leaving about 5,000 to 7,000 others injured. The exact cause of this incident remains unknown due to the lack of evidence, lack of witness reports, and the complete destruction of the LPG tank farm. Both of the incidents are caused by boiling liquid expanding vapor explosion (BLEVE). Pass to the next presenter.
Let us move on to the process flow or methodology of FMEA analysis. Prior to FMEA development, the asset is defined in the term of process of interest and then subdivided into asset item, or also called component for the equipment. Brainstorming process is done to list down all the potential failure mode, the effect of the failure to the equipment, and also the causes of the failure. All the potential failure of the equipment are listed for assessment and then rated into 3 categories, which mentioned earlier: severity, occurrence, and also detection. The risk priority number, RPN, is then calculated by multiplying all these 3 categories. The criticality of the failure mode is then rated by the RPN that is exceeding some threshold value. And then from this, the recommended action are proposed, and then the RPN will be recalculated, and by right, the RPN should be reduced.
Let's take a look at the result of this project. This table is FMEA for shell of a spherical storage tank. The most severe failure mode is fatigue cracking with RPN of 384. Fatigue cracking can cause shell failure and leakage of contained material. Potential causes of this failure mode are cyclic loading and stress concentration inside the tank. The current process control is regular inspection and monitoring. It is recommended to always monitor growth of fatigue cracking and increasing the inspection frequency. Once action is taken, the RPN had been reduced to 24. Another failure mode identified for shell of a spherical storage tank are corrosion, wet failure, and fire and explosion.
Next, let's take a closer look at the FMEA analysis for the tank heat component of our system. Several potential failure modes were identified, including cracks on valves, severity rating of 8, corrosion, severity rating of 10, fatigue, severity rating of 7, and buckling, severity rating of 9. The most severe failure mode identified was corrosion of the tank 8, with a risk priority number (RPN) of under 60, which could result in leakage due to the presence of a corrosive environment. To address this potential failure mode, recommended actions were put in place to improve corrosion protection by using corrosion-resistant materials and to increase inspection frequency. These actions were assigned to the Quality Department, Engineering Department, and Maintenance Department with a target completion date set for 1 to 2 weeks after the FMEA analysis. As a result of the actions taken, the RPN of each failure mode was reduced, with the RPN for the corrosion failure mode being reduced to under 28. Overall, the FMEA analysis provided valuable insight into the potential failure modes for the tank 8 component and allow us to take proactive steps to mitigate risk and ensure the reliability of our system. Now I'll pass the floor to Elia.
This is the FMEA result for the third component, which is nozzle. So the function of nozzle is to connect tank to pipes or other equipment. So from the FMEA result, we can see the highest rating of RPN is for the failure mode of fatigue cracking. So fatigue cracking usually due to cyclic loading and stress concentration. So from this, we can see that mitigation action is proposed in the term of implementing RBI plan to estimate the remaining useful life of the equipment. And from this, it can reduce the RPN value from 315 to 72. And also, we can note that other failure mode that can happen at nozzle is nozzle blockage, nozzle leakage, overpressure, and corrosion.
So next, we look at the FMEA result for the manhole of the tank. So the most severe failure mode is corrosion of manhole cover with the risk priority number of 224. The corrosion occur on the manhole cover can cause the leakage of the tank content. The potential cause for this failure is due to the exposure of harsh weather condition. So our current process control for this failure mode is to have regular inspection and monitoring. So it is recommended to have predict ITPM schedule, which is to do visual inspection to ensure that there is no sign of corrosion occurs and replacement can be done if needed or found necessary. So when action has been taken, the RPN has been reduced to 56, and other potential failure mode is such as like cracking of the flange, deterioration of the gasket material, corrosion or loosening of bolts, and failure of lifting equipment during maintenance process for the manhole. So I will pass the floor to Iman Danish.
This is the FMEA for the support structure. There are 5 potential failure mode, which is corrosion, foundation failure, bolting failure, human error, and also welding failure. The highest RPN is the corrosion, and the potential effect of corrosion is that it could reduce the shell thickness, material losses, and also shell leakage. The potential cause of corrosion is that it is exposed to corrosive environment such as air and humidity. Current process control is protective coatings, and recommended action is that a regular inspections and maintenance to detect and repair corrosion damage must be taken by the maintenance team. After the action is taken, the RPN is reduced to 84.
In conclusion, spherical storage tanks plays a critical role in storing liquids and gases such as liquefied petroleum gas and liquefied natural gas across various industries, including oil and gas, chemical and petrochemical. Their unique structural design allows for maximum storage capacity with minimal footprint, making them highly efficient. However, they are susceptible to potential failure modes that could pose serious risk to people, assets, and the environment. The FMEA analysis performed on 5 components of a spherical storage tank successfully identified the potential failure modes, with RPN serving as an essential measure of the priority of failure modes to be mitigated. Recommended measures such as regular inspection and maintenance, improving material selection and welding techniques, applying protective barriers, and enhancing safety procedures are necessary to prevent and mitigate associated risk. Implementing these measures can significantly reduce the risk associated with the operation of spherical storage tanks and ensure safe and efficient operations in the industry. Thank you.